Okay, so have you looked through the material I passed to you yesterday?
Yes.
Yeah, I think maybe I think I mean for this session maybe you can unmute. I mean if there's no noise, maybe you can unmute so that later we can have a better interaction. Okay. Yeah, because I don't want this to be a way of lecturing, but rather it's a kind of the tutorial or lab. So whenever you got any questions, feel free to ask. Okay. Then also like provide the feedback to me in time. Okay. So yesterday I actually listed out some of the questions. Okay, so here, so later we will go through. I mean, if you're able to answer all those questions, meaning that we actually have a successful session. Okay, so I think for this session, it will be the first lesson. So meaning, I think the keyword for this session will be the hello world. Okay, you know that hello world is actually for most of the programming language. This will be the first lessons to test the development environment and also like come up with the first program. Okay, so I think the same thing happened for O2DES is that I want you to do this like a hello world at the beginning so that at least to test that all the development environments is ready, and also is like for you to gain some kind of the confidence to see that you see that now we are able to do to develop a simulation model. Okay, so I think this is the purpose of this session, and hopefully we can finish this within the 1 hour's time. Okay. So here listed are some of the training objective of today. The first one, actually it will be the meaning, this three part, okay? The first part, I will show you that how to set up this development environment, just in case that some of you or maybe someone watching this video record might have a problem of doing this. I will just show you what are the key steps, okay, we need to make sure. Then the second one is I will show you how can we come up with this hello world simulation model in a very fast way. Maybe just a few minutes, we're able to come up with this like very first simulation models with O2DES.NET. Okay, then using this model, I trying to explain to you that what is actually the discrete event and what is a simulation clock versus a CPU time, the CPU clock time. And also is that I'll show you that how an event is scheduled in the so-called discrete event simulation model. Okay, so I think this is basically through this hello world simulation model we should be able to understand. I mean, this three concept. I mean, later if you have other questions, feel free to ask. Okay, and also this is the purpose for this like pre-training. I mean, it's actually the way to collect more feedback from you. And the third part will be like, I will try to like slightly extend this hello world model so that we're able to show you the concept of the static property, dynamic property, and events. And after that, I'll try to see that demo to you that how do we like randomize some of the parameter setting, like time intervals, and also what is the role of this random set. Okay, so I think I will go through this slides later when there is a need, but I think today mainly I will show you the program, okay, and to gain more on the hands-on experience. Okay, so the first one will be like a development environment. So what we are actually using is this Visual Studio 2019. This is the latest version. And Visual Studio actually got this community version. Okay, so yeah, sorry, I think it might have some noise. So
I think Hongtan is your side, right?
yeah, it's okay.
I
Yeah, maybe mute
Yeah.
first. Later when you want to speak, I can unmute. Yeah. Okay.
okay. Sorry,
But,
sorry.
yeah, no problem, no problem. I think the main purpose is that I want to have a frequent feedback from you. So feel free to speak anything, but remember to unmute when you speak. Okay, so yeah, okay, so this is actually the Visual Studio community version. I don't know why I'm in the Chinese version, but I think it's okay lah. Okay, just look into this part, Visual Studio community. So this is the software we're going to use. So in case you have not installed this one, just click the download Visual Studio community version. Okay, then you can actually goes to this part. Okay, start to install. Then you can see that it's actually automatically downloaded here. So I think I want to show you the things, what are actually the components, okay, we need to run, okay, we need to install, okay, for the Visual Studio, because Visual Studio is not only for C#, but also for the other language like Visual Basic, like I think even like a Python is actually supported by the Visual Studio. But what we are going to use here is the C#.NET, okay? So that's why I want to show you some things. So I will do modify. Yeah, I mean, if it's the first time you install, then this will be some things you will show immediately after you run this installer. Okay, so see that these are actually all the components you can choose to install. So basically here we need to install this one .NET desktop development, and probably the Universal Windows Platform development, and also this .NET Core cross-platform development. I think these are the three components you can choose to install. For the other ones, I mean, if you're interested, for example, you want to have the web developments, Python, then you actually feel free to install the other component. And other than that, you can jump to this individual component. I will suggest you to also take this one, the class designer. So some of cases when we come up with the data structures, we define some like classes. So this class designer will enable you to have some better view on this class diagram. Okay, so in that case, sometimes the pictures, image can tell more story. So that's why this one better to take it. And yeah, I think that's all. Okay, you need language packs. I mean, if you some of our developer here actually from China or from Hong Kong, so you can either choose a Chinese simplified or Chinese traditional if you like. Okay, also you got other language if you wish to install. Okay, so I mean, after this one, you can just like click the install, then just wait for the completion of the installation. Then you are able to have this Visual Studio. But one more thing I think we need is actually the other thing called the .NET Core. Okay, so this will be some things you can I mean install in a separate way. I'm not quite sure whether the latest Visual Studio can install this .NET Core. I mean, in the integrated installer. But I mean, to make sure that this is installed, you can go to this .NET. Okay, this .NET. Okay, you can go to that this page. Okay, then download this .NET Core SDK separately. Okay, so when you go to this one, choose the one on the left, .NET Core. So what's the difference between .NET Core and the .NET Framework is that this is actually a cross-platform. You can run whatever application developed on the .NET Core using either Windows system or the Linux, okay? But if you run on the .NET Framework, then you have to use a Windows machine. Okay, so for us is that we are choosing this one, or the .NET, O2DES framework. O2DES.NET is actually now developed under the .NET Core. Okay, so you choose this one. The latest version we're using is the .NET Core 3.1. So use the latest version. And because we are actually using that for development purpose, so that's why we need to choose this SDK rather than the runtime. Okay, so just click this one. .NET Core SDK, then you can see that this one got downloaded. So after download, it just run and waiting for the completion. Then that's all. Okay, so these are only the two software we need to install. Okay, for us to start building a simulation model within Visual Studio. Sorry, O2DES.NET. Okay, then we're going to use a Visual Studio 2019 here. Okay, so we wait for the, yeah, sorry, it's on another screen. Okay, it will show something like this. Okay, so what we'll do is we'll continue with without code, meaning that we're actually starting a new environment. Then I will show you step by step that how to. Sorry, where is it? I'll show you step by step is that how to start with a new project. Okay, simulation, or there's a simulation project. Okay, so after this one, so we can create this file, create a new project. Now for the testing purpose, we just choose the first one, console app bracket .NET Core. Okay, we choose this one, then we click next. Make sure that this is for C#. Okay, you can see the icon of the C# here, the C#. console app.NET Core, and it's state that this program can run on Linux, Mac OS, Windows console, so it was supporting cross-platform. Okay, then just give any name. So now maybe I just put as a default, like a console app 6, whatever. So create. Okay, so now you can see that we have a default .NET Core program. So what this default program is doing is just to print out a line called a hello world. So this is actually a hello world of the C# program. So just want to test that whether the Visual Studio installed correctly, whether the .NET Core installed correctly. So what you can do after, creating this new project is that you simply can click this one, okay, play or debug of this program. So what you will see is this console window comes out. Then we'll show you the play world, hello world. Okay, then got some like a message. Then press any key to close this window. You can ignore this part of the message. Just look into this one. As long as you are able to see this hello world, meaning that you are able to successfully run a C# program. Okay, meaning that just now the installation of Visual Studio, the installation of a .NET Core is successful. Okay, after you see this one, hello world. So actually it's very simple. I mean, don't need to really understand the full like a scope of the C# syntax, but just like run the default program is showing this, meaning that, okay, it's successful. Okay, now is that we want to build our first simulation model, okay, with O2DES.NET. So what we are going to do is that the first we need to include the O2DES.NET library. Okay, so the way we do that is that you click this tools, NuGet package manager, manage NuGet package for solutions. Okay, so we need to install the package of the O2DES.NET framework. So what we are going to do is we click this browse. Okay, we search for O2DES, O2DES. Okay, maybe net. Okay, because now you have so many like sub library. So we can choose the first one, O2DES.NET. Okay, you just click this one, choose a project you want to install to, then click install. Okay, so the latest version is here, but I think at the time you watch this video might already have some updated version. Okay, so it doesn't matter. So as long as you see this version number appear after this project, okay, meaning that okay, it's installed successfully. Okay, and if you want to further check whether the installation is successful, you can also go to here, dependencies, packages. Then you see that this one appears here. Okay, it means that a package is installed. Okay, the package is installed. Okay, so now is that we actually have answered our first questions here. I mean, met our first training objective is to set up the development environment. As long as you have the Visual Studio, come up with the first C# program, then you are able to install the NuGet package for the O2DES.NET library. Then we have successfully set up this development environment. Now we are going to the second one, is that we need to build the first simulation model of the hello world. Okay, so how do we build a first simulation model? We need to click the one file for this model. So what we do is we go to the project. Okay, so actually this is called a project and this is called solution. So in a C# development environment, we have this solution might contains a multiple project. So this purple one is called solution, and this green one called a project. So now is that we at a project level, we right click, then we add one, it can be a new item or the classes. I think now let's choose a class. Okay, so click this one. I mean, if you click item, it will appear the same thing. So just choose the C# class. So now we want to create this a class. We call this the model. Okay. So now we create this model. We don't want this model to be an O2DES simulation model. So how do we do that? We use this one to extend O2DES.NET. Okay, so this is actually the namespace of the package we just installed. Dot sandbox. Okay, so sandbox is actually meaning that it's actually a protected environment. You can play around with this safe environment, so we can put a lot of the properties. We can define them. Okay, in this sandbox, we can define the dynamics, interaction, whatever. Okay, inside this sandbox. Okay, so this is actually a template. We can call this as a kind of the template, or maybe in the C# we call this as a abstract class. Okay, for us to build any of the simulation model. So this one we call the sandbox. So now we define this model to extend from this sandbox. Okay, so what we are going to do here is that we want to create a event. Okay, then we do some things in this event. Okay, then later we will let the simulation run with this event. Okay, so how do we do that? Is we need to define an event, maybe just a call my event. Okay, so this is actually a simple way to define one event. We just to say this actually all the event actually here in the O2DES.NET the simulation event. I think this event is different from the C# event. I think we don't need to like mix these two concepts, because in the simulation, no, sorry, in the C# they actually have this keywords called event. So this is not the things we're mentioning here. Here we are talking about the event of the discrete event simulation. Okay, so we are now define the events under the discrete event simulation. So this event we call this my event here. And it's actually the defining an event is no more than just define any of the method, a private method with no returning data type, meaning that the returning data type is void, meaning that we don't need to return anything from this method. Okay, so this one we call the my event. So what we do in this event is to say that, okay, I want to print out things called hello world. Okay, hello world. But if you see that if you just do this one, it's actually the same as just any C# program. So what we are going to do is here is we just show what is the time now. Okay, we just show the time. Okay, then see hello world. Okay, so what do we show for the client? The time is we put there's a clock time here. Okay, so this is the way that we can print out this hello world at a certain time. And actually, this is the old way of the writing a string to the console. But if you use the latest, according to the latest C# standard, you can also write in this way. Okay, I think this also will be easier for you to see. Okay, now we just say now it's a time, then we show hello world. Okay, so after this, what we are going to do is I want to schedule the next event at the next time. Okay, maybe after the 5 seconds. Okay, so I schedule my event after 5 seconds. Okay, so what we are going to do is here, we want to schedule the next event after the 5 seconds. So what is this a program is doing? What is this simulation model is doing is that every 5 seconds it will print a message called hello world, okay? And also showing the time of calling hello world. Okay, so you can see that the first thing will happen at a 5 second, then the second one will be 10 seconds, 15 seconds, etc. Okay, so this is what is this simulation model is doing. But it seems that we actually have a missed something. Okay, so you can see that the first event, when we execute, will trigger the second event. When we come up with the second event, we'll trigger the third event. But where is a place that we trigger the first event? So that's why we need to come up with a constructor, okay, of this class to say that, okay, now if we want to sorry, okay, at the time that we construct any like a simulation model object, okay, so what we are going to do is we schedule the first my event at the current time. Okay, so I mean at the time the model is constructed, okay, then you will schedule the first event. Then when this event is called, then it will come, we'll call the second event, second will call the third event. Each time when the event is executed, is invoked, then it will print out this clock time and the hello world. Okay, so basically this is the models I'm going to show you very soon to show that how what is the running result of this one. Okay, so in this file we have defined a model. So now we want to use this model and to run it. It's like a toy. Okay, just now we created this toy, but every time if you want to play with this toy, then you need to execute another like a set of the program. So this is what we are going to do here in this main functions of the program class. So what we are going to do here is we want to create this model, this simulation model, and we want to run it. Okay, we need to run it. Okay, so let's see what is the result of this running. Okay, you can see that we've actually printed out one message called that at the first day, first year, first month, and the first day. Okay, at the time 0, midnight, we actually have a message print out called hello world. But you may say that what happened, okay, to the other event? Just now you said, okay, I actually scheduled a second event, third event. So where are they? Okay, this is because the way we play with this toy. If you just say the wrong bracket, meaning that we're actually running only the first event of this model. So if we want to run more, no problem, we can do that. We just key in a number. 10, meaning that we're actually going to observe 10 events. Okay, we let a model to run for 10 events. Then we want to see what is the result. So let's click this one and show again. Then we actually have this 10 events at time 0, 5 seconds, 10 seconds, 15 seconds, 20, 25, 30, 35, 40, 45. Okay, so this actually showing the hello world of running 10 different events. But you can see that in order to run this 10 events, what we have done here is that we only define one event, then we let this event to call to trigger itself. Okay, so here is actually introduced some of the very important concept. The first is what is actually an event, and what is an event play a role in a discrete event simulation. You can see that everything is driven by event. At the time we construct the model, we need to trigger the first event. When the event happens, we do something, but we also need to trigger the next event. So you can see that, and also here we see we have some time, and the place we actually schedule and execute the event will be discretized, meaning that we only observe the event at the time 0, 5, 10, 15. Okay, so actually this is called a discrete event simulation. But later also I want to introduce you the difference between the discrete time simulation and the discrete event simulation. So later in the extension, I will try to introduce to you. But now is that as long as you are able to come up with this program, you can say that yourself can do a discrete event simulation with O2DES.NET. Okay. So now I want to just continue and introduce to you some of the other kind of the little bit more features around how can you play with this simple toy. But before I continue, may I ask a question? May I check that whether you got any questions regarding what we have done here? So any of you got any question, or you are okay with it?
Okay with it. Okay with it. Okay with it. Okay.
I heard a
Sir,
lot of
I have
okay.
one question.
Yes.
In the sandbox, we can see there is another thing also, sandbox and I assets. So, like, you will explain later that part.
Sure, I will explain later. Yeah, probably it's yeah, I will explain later. And also this asset is actually regarding the static static property which I'm mentioning here. So I think later I will continue to introduce about this.
Okay,
Okay,
okay.
yeah, don't worry. Yes.
And sir, one more very general question. Like when we are calling the constructor model, it is
Yes.
going to the event. Then why is it not firing the another event which is written inside? Why does it need dot run?
Uh, so sorry again. Can you repeat your question? Is you see here we got a
Yeah,
your
we
question
have
is why it goes to this event? Am I right?
uh no from the program we
Yeah.
come to model. Yes. and this will bring us to the model there inside. So why do we need, I can understand because I have seen this code many times. I
Yes.
can understand that to run 10 iterations, I need to write model.run. But why, like after model, why it is not going to the event automatically?
Uh, why it's not going to the event automatically?
Automatically,
So
yes.
meaning what? Meaning are you asking why we need these things or why we need
No, no.
this wrong?
Why, yeah, why do we need run? If suppose we want to run only a one event, not 10 event, then automatically the schedule should go to the next event.
You mean this one?
Yeah. Yeah, if we run, it should run one event, one full event, right? If
No,
if
no,
we
no.
run,
The question you are asking is
uh,
why not? Why we need a model dot run, or you are asking why do we need to specify 10?
no, uh, we need model dot run if we have to run 10 iterations.
Yes,
Okay, but if I need to run one iteration only, then I
yes.
need, then it is not required.
It's not required. Yeah, I mean, if it's just a dot run bracket, then by default, it will only
O-
run for the next event.
Okay, okay,
Yeah, it will only run for the next
for
event.
the next event.
Yeah,
Okay,
I
okay.
was trying to say that actually, I mean, for those who are familiar with commercial software, you may have this question. Why? I mean, if the dot run bracket, so basically meaning that it's just a continual run until the end of the world or until you give a further instruction, right?
Yeah,
So this is why this dot run. Okay, I mean by default, people may understand. But I should say that now is we actually running this model in a single thread environment. Okay,
okay,
so
okay.
meaning that the next statement, if we can see that a model, for example, you have some like thing like model stop, okay,
Yeah,
something,
okay,
then you can see that because it's a single thread, okay, so
okay,
before this one is completed, we can never touch this part.
okay,
So
okay,
this will only happen if you have a multiple thread. For example, if you
okay,
put it in a GUI, then we can let it run. Okay,
okay,
then we have a separate thread for us to give instruction to say, now it's a time to stop. So I think
okay,
these are some things our team is
okay,
doing. Riza is actually implementing something on this thing to support. By now is that we want to make it also workable under a single thread environment because it's actually a simplest environment. Okay, we're going
okay,
to have. So we set this as the default. If it do not give anything by default, it just run for the first event.
okay, sir. Okay,
Okay, yeah, but I think it's good to ask this question.
okay, sir.
Okay, yeah. Then if you have a do you have any other questions?
No, sir.
Okay.
Thank you, sir.
Then how about the other people's? Are you okay? So if you're okay, I will continue from here.
I'm okay.
Okay. Okay. So okay,
Oh,
no
okay.
problem.
But having just that
Yes.
the size now is very good, but just now the size is
So small.
very small.
Okay.
Very yeah.
Okay, I'll pay attention next time. Yeah, maybe I'll use a
Prof,
lower pixel resolution. Yeah.
Prof, can I ask a small
Sure, no
question? Like
problem.
this page, like line 9, like create a new model, right?
Yes.
Like the green model, right? This
Yeah.
one refers to the first file, right? The model file, right? So,
Yeah, this refers to a model defined here.
oh,
This
okay.
class. Yeah.
Oh,
Okay,
okay.
maybe I just give a background of the object-oriented programming. So object-oriented programming have this concept of the class and the object. Okay. So I think
Yes.
maybe I just like spend a few more minutes to just get this background. Just lay down this kind of the backgrounds for you so that we're easy for you to understand why this is called O2DES. Okay, because it's object oriented. You see that simulation, or if they talk about the simulation, people may consider this as a procedure or the sequence of the events. So I think this is actually corresponding to the original concept of the programming. So what is a programming mean? Is actually we come up with the procedure so that a computer can execute the procedure from the step 1 to step 2 until the end of procedure, then it's end. Okay, so this is actually the old way of doing the programming. Then we call this a procedure-oriented programming. Okay, then if you like use an old approach, like event graph, so later actually I'm going to show you. Okay, so if you see that event graph, meaning that we're actually defining a simulation using the event and the triggering of the event. Actually, these are some things we're doing here. But if you just want to specify the procedure 1, 2, 3, or step 1, 2, 3, so this is actually a procedure oriented, okay, programming. Okay, but now it's a object oriented programming, meaning that I will define the structure of the system, okay, the model, before I run it. Okay, you see that this actually got some difference. If a procedure-oriented programming, meaning that in a program, I will directly tell what is the first thing you need to do, what the second thing, third thing. Okay, I will have try to like branch the decision, the logic. Okay, so this actually come up with the procedure, a flow. Okay, of the logic, a procedure. But what we do for the object-oriented programming is that before that, I first define object. Okay, to say that this is a thing number. This is the first kind of things. Okay, this is the second kind of thing. For example, these are the model. These are student. These are teacher. These are classroom. Okay, so I define all those object first. Okay, before I really call it to do something. Okay, it's like the toy. Now we're actually creating the toy, but doesn't mean that we start to play with it. Okay, I can create and do nothing, meaning that in this program, if I remove these things, okay, I remove the model that are wrong, meaning that I just create and do nothing. It's also fine. It's also fine because to create this object is one thing. How to play with this will be another story. Okay, so this is actually the way we define the complex. We use this way to define the complex system. So that's why now when we move into the simulation, discrete event simulation, if you want to describe for the complex industrial system, let me find that this object-oriented way is actually a better way compared to a procedure-oriented way to doing a simulation model, because actually we can define all different components. I mean, at first, and specify the relationship at the first before I trigger something to start moving, to let the system start moving. Yeah, and when we define them, we can define them like object by object or class by class. Okay, so this is actually what is the way we model it. And also is how to differentiate the concept of the class, then concept of the object. Okay, class, I mean, by the name, is actually a type of the object. It's a type of objects. For example, students, okay, it's actually a class. But student, we have many students here. Okay, so we have a student number 1, we have a Monica, we have a Hongdan, we have a Sijie, we have a Xinju. We have a different students here, but we define you as one type we call class. Okay, so this is actually the meaning of the class. We define the class, then we see that this is a class called a model, then every model must have this my event. But here, we have this a small model to see that this is actually an object of this type. Okay, then because this object is defined as this type, so this object will have all the things defined for this type. And also we can have another object called a model 2. It can also be a new model. So this will have the same type, okay, but they are actually a different object, meaning that the event of the model 1 will be different from the event of the model 2. The property attribute of the model 1 will be different from the property of the model 2. Okay, so in this case, for example, if we define as a port, a terminal, okay, then we can see we have a terminal number 1, terminal number 2. So this will be the different terminals, okay, but have the same type. Okay, so I think this part is it clear for you?
Yes. Thank
Okay.
you.
Yeah, no problem. So in that case, we can continue to the next one is when we want to play with this toy, okay, this model. So what are the ways we can play with it? I just want to show you some of the example. So just now we come up with this 10, right? So it's actually come up with a 10 event. So I think it's very simple. If I change this number like 30, 20, then what you will see is just increase the number of events executed here. But now is you may say that, okay, maybe I don't really care about how many events in the system. For example, if you want to run the simulation for the port terminal, there's millions of events inside. So when we want to instruct give an instruction to run, I do not really to care whether you got a 1 minute event, 2 minute event. I want to run the simulation model for 2 hours or maybe run for 1 day. Okay, so if in that case, how can we instruct the model to run? So in that case, we can simply change the parameter here from the integer, which is specified the number of events, to a time span. So now if you see that I want to run this simulation for like a 30 minutes, okay, I can just write in this way. So we can run the simulation model, then we can see that it will continue to run different events until they reach the time of the 30 minutes, okay? Then now if we want to like change this to another number, also can, no problem at all, okay? So we can just specify a time span here to indicate that how long you want to run this simulation model. Another thing is, another part, another different way you can play with this toy is to say what is the time you want to terminate. So in that case, we need to specify a date time, okay? The date time is actually a time point. So we can say, now I want to specify a date time. I want to run this simulation until the first year, first month, first day, 0 o'clock, 20 minutes, 0 seconds, okay? So if you specify, okay, this one as a date time, so you can understand this structure. If we like have this, you can actually check this one. What is the meaning of each parameter here? So first one will be year, month, followed by day, hour, minute, second. So you can see that this is actually meaning that I want to run our simulation until this time, okay? So in that case, if you run the simulation model, we'll see that it will run it until it's reached this 20 minutes of the first day, of the first month, of the first year. Okay, so this actually we control the simulation run by date time, by the time point. Okay, so now I think by here you can understand what is the difference between the time span and also the date time. Okay, the time point. So actually we can do some things like this. Okay, we let the t, okay, to be the current clock time of this simulation model. Let me see that I want to use this t times time span of the 20 minutes, for example. Okay. Then I just want to run this model until this new t. Okay. So in this case, we have the same effect. Okay. In this case, we have the same effect. Okay. So why is so? Is because this clock time is actually a time point. A time point. So what will be this t at the beginning? Okay, you actually can break here, then you can check the value. So this actually debug mode. So you break here, you can actually mouse over to see the value of this one. So you can see that at the beginning, this t, the value of this t is actually the 0 time of the first day. Okay, so after you add this time span of 20 minutes to that, okay, so if you break here, we can see that this t become, sorry, I think this is too small, but if you look into here, this t actually become the 20 minutes of the first hour of the first day, first month, okay, of the same day. So you can see that this t is a time point, a date time, okay, and here is actually a time span. A date time plus a time span equals to a new date time, okay. So you control the simulation run by the date time, it will terminate here. So this is actually the same, exactly the same effect as to see that, okay, you just run for this time span without having this trouble things here, okay? So it's the same effect. Okay, so it is fine for you? Okay, so may I have a quick chat? So what are the difference between a time span and a daytime? Anyone can tell me?
Time span is the duration you want the simulation to run for. Date time is the exact timing you want the simulation to stop.
Yeah, it's a time point. It's a daytime is a time point. Time span is a duration. Yeah. So I think that's
I have a question.
Yeah, yes,
I have a question here. So if for some of the simulation model, what if I want it to run for, like, for example, 30 minutes, but I want it to, at the same time, it has to run for 10 times of 30 minutes?
10 times of 30 minutes.
Yeah.
right? So in that case, we can just add a for loop here. Okay, so we can just say I want to like iterate from 0 to 10. I want to iterate for 10 times. Okay, then each time I just want to run for 30 minutes.
Oh, okay.
Okay, then it's okay. So in that case, we just run for 5 hours.
Oh, okay.
Okay, 5 hours will stop. Okay, but the good thing of doing that is that in this duration, you cannot observe anything. I mean, simulation just keep running, but actually you can see that, okay, so after this, I want to like print out something. Maybe I just want to like read the key and pause for a while. Okay, then when people click one button, okay, one key, then you will continue to run. Okay, so you can see that 30 minutes will stop. So if I key something, then we'll continue to run for another 30 minutes. Yeah, probably I think I can add a little bit, change the font size. Oh, good for you, right? Is it? Looks nice.
Yeah, yeah.
Okay, so you can see that I can actually add this array key. Okay, so you can see that in some of our study now is that we want to have the hourly statistics. So the way we do that is that we actually run for 1 hour, then we pause. Okay, then we actually read something, a lot of information from the simulation, then we just continue to run again. Okay, so here we have a array key, but in our real application, this one can be write some information into the CSV file, into Excel. It can also be like we display some things to a GUI, etc. Okay, so this is what we can do here.
Okay.
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 Yeah. So let's come.
Sir,
Yes, yes,
sir,
please.
sorry to interrupt, sir. Two questions.
Yes.
First, like CJ said that first we have we have 10 runs, and then we each run will run for 30 minutes.
Yes.
Can we make can we schedule the first event of run 10 times, and inside that event we schedule another event which runs for 30 minutes? Will that be fine, or we have to use a for loop?
Okay, so what you are talking about is actually how the events will trigger each other. Like a first event, how it will trigger the second event. Am I
Yeah.
right to say so? So this
Yes, sir.
one is not considered as a run control. It's actually defined as the logic of the simulation model. So what you are talking about is actually whichever inside the simulation model, but what we are talking now here is actually from the outsider, okay, which have a totally
Okay.
nothing control with what is happening inside the model. I mean the mechanism of the model. It have a nothing to control with those things, but actually I only control the wrong, the
Okay.
time.
Okay.
Yeah, it's like
Okay.
a toy. It's like a toy. I make
Okay.
this toy for you. So as a user, what you can do is just click the button, then the toy will run, will make sounds, will make some movements. Okay, then you
Okay.
click another button, it stop. Or
Okay.
maybe it's just a click button, it will show something to you. Okay, then you
Okay.
click a button, it will disappear. So something like that. But now is that you cannot do, I mean, at this program phase, you cannot do more than what the simulation model exposed to you to control.
Okay. Okay.
Okay, so but if you, I mean, like a problem you asking just now, if you want to do something like this, you need
Yeah.
to, how to say, open this toy. You need to
Yeah.
change like a circuit inside. You need to put another component. You need to connect. Okay, in order to
Yeah.
provide additional function or change or
Yeah.
reprogram so that you can change a mechanism of how the toy will run, will operate
Okay.
inside. Okay, you
Okay.
see that
Okay.
this is actually what will happen here. So I think I will later will continue with this one to see that how do we adding a more logic into this tiny toy, the model.
Okay. Okay, sir.
Okay.
Sir, okay, sir. Second question, sir.
Yes.
In the slide, you have speed, like sim dot run speed 10. When I executed it, I did not get any result. Like, what it is used for? Maybe I don't know.
Okay. Yes. Okay. It's a good question. It's a good question. Okay. The speed is something that's very interesting. Okay. So if you write in this way, yeah, actually, I think at the beginning I want to skip this part, but since you are asking now, I want to show to you so how this will be effect. I mean, Sijie just now ask a question. I think it's actually a very good for starting introduction to this speed. So this speed is actually meaning you want the simulation to give you kind of the virtual experience. Okay, so actually this is some of the keyword, the virtual environments. Okay, this is actually one type of the simulation wrong, which in the sense that actually give the person, the observer, the player of this model a sense of the time for the virtual world simulated by the model. Okay, so if we put the simulation speed by 1, it meaning that we want the simulation run at the same speed as a CPU clock. Okay, so meaning when the CPU, when a real time passes 5 seconds, then want the model to run for 5 seconds. Okay, if you like run for another like 10 seconds, I want it here to run for 10 seconds. Okay, so in that case, I will show you the effect. I will keep the program run. Then actually you see that nothing, right? Yeah, let me see. Okay, let me see. I think it's better. I mean, just now I keep a 5 second up. 5 second might be too long. Let's put at 1 second. Okay. So here you can understand, right? Okay, just now it's a 5 second. Now I change this to the 1 second. So in that case, if I let the program to run, you can see that actually you see nothing. Because why? It's because at the time you run this statement, at the time you run this statement, actually nothing happened. I mean, in the real life, there's nothing happens. Okay, so it's actually the time 0. I mean, at the time 0, there's nothing happen. Okay, so actually the simulation look into a CPU clock to see that how many times you have passed. CPU clock tell the simulation model, okay, actually there's nothing, there's a 0 second pass. Then the simulation say, okay, in that case, I will do nothing. Okay, so this is actually what is happening. But since the program run until now, we have a speed too much. We roughly estimate that probably does have been a 30 second already passed. So if you clear something, you will see that the next time if you want to review back to the simulation model, it shows you that okay, 47 seconds already passed. So the simulation is actually catch up to run all the things happening within the 47 seconds. Now if you like click some key again, we'll say okay, now it's 1 minute and 3 seconds. Okay, so that's why it's actually keep executing the events according to the real like time scale. It's according to a real like a CPU time. Okay, so this is actually what happening inside the simulation model. Okay, so according to the speed 1, so meaning that we put it in short is that this speed actually a little bit complicated. It's actually give the user a sense of the realize the time passing, meaning that if you like keep observing each time I press the key, it actually will check the CPU time. According to the CPU time, it will decide how much time it will simulate in the virtual world. Okay, but the thing is, if I want to change the speed to 10, okay, so meaning that every time, okay, for example, now we like wait for 1, 2, 3, 4, 5, the 5 second, we click. Then you can see that the real time we actually pass a 5 second, but in the simulation world, actually 50 seconds already passed. So if you press the key again, you will see that another like 80 seconds pass in the simulation world, but in the real life, it only passes 8 seconds. Okay, so this is about the speed. How do we use the speed? But I don't suggest a beginner to use any functions for this speed. Yeah, this is
Okay.
only for like a UI. When we come up with the UI, usually we use it as speed to decide that how fast we want to run the simulation. Because we need to do the animation, so we need to give people a real sense of the time passing.
Okay.
Okay?
Okay.
Yeah.
Sir,
So yeah. Yes.
one more linked question, sir. When Ratnaji Satish talk to you, they tell that we have run for 10 days or 60 days. So is it this speed only that they are running or something else?
No. I mean,
Yes.
okay. So I think probably I should have a maybe later lah. I will give you some like introduction of the classification of the simulation running. So what we are doing here, we call the analytical simulation. Okay, so simulation actually have this two category. One is called analytical, the other is called virtual environment. So this speed is actually for the virtual environment. Okay, but all the things our center is doing is for analytics. So we are using analytical simulation. So in that sense, we don't care about the virtual experience. We don't need to care about the sense of the time passing. All we have is actually regarding the time stamp. We only need to know that at which time, which thing happens. That's all we need to need. We need to know. We don't need to really wait for the time to pass. Okay, so in that case, when they say that the 80 days or whatever days, so basically it's meaning that here we got a time span of number of days to be 40 and 80. Okay, and this one can actually finish within milliseconds or seconds. Okay, so
Yeah,
this is
yeah,
actually another concept I want to, actually the question I want you to answer at the end of the this lesson is that what is the difference between a simulation clock and a CPU clock? Simulations clock time and a CPU clock time. Okay, so yeah,
yes,
probably
sir,
anyone
yes,
can answer this question. What is the
yes,
difference, or do you sense the difference between the simulation clock time and the CPU clock time? So what is the difference?
uh, actually, sir, this simulation clock is present in the sandbox, and this is not the real time.
Yes,
This is the start of the time, like 111 and
yes.
001. So when we give run, we can see this message multiple times. But if we have if we do datetime dot now, then we will have like the present time, and it will increase after once, like it will increase in milliseconds. But here we will get, if we give from time seconds one, then it will increase in 1 second or minutes,
Can we
like
make an
that.
answer shorter? Yeah, I know what you are right. You are saying here might be right, but maybe we just need a short answer. It's like what are difference? I think what you write at what you said at the beginning is quite correct. Is
Yeah,
that
yeah,
simulation
yeah.
clock is a clock time observed. I mean, present only inside the sandbox. Okay,
Yes,
and
correct,
it's a
correct.
virtual time. But
Yeah,
actually, clock time, the CPU clock time is, I mean, most of the case is actually the real time.
current time.
But
Yeah,
this
real.
real time is actually recorded or tracked by the CPU, okay, by the
Yes,
CPU of the computer. So because you're using different computer, maybe the time you see is a different. But usually we use this one as a real life, like the clock time. So this will be the difference. So when we say that you run the simulation for 40 days, 80 days, I think the important is to see that 40 days, 80 days, are you referring to the time passing in the simulation clock time or the CPU clock time? Whether it's a CPU time or simulation time, make it short. Okay.
yeah,
Yeah,
simulation
yeah.
time.
So
Yeah,
I think this is some things we need to have this a sense. Okay, when they
yeah,
say they run simulation for 2 days. Wow, your simulation is run to too long. No, actually, it's not. It's actually simulate for 2 days. It's a simulation time. Okay, so I think these are some things I want to bear in mind. Okay, so
yeah.
yeah,
Thank you, sir. Yeah,
yeah, no problem, no problem. So I think the other ones, are you okay with this one? I think this is actually one of the questions I listed here. Okay.
Yes, I'm okay.
Okay, so I think most of the case when we see the model dot clock time is actually meaning it's a simulation clock time because the model is a sandbox. Okay, Ken.
Okay. Okay.
Yes, yes. I think let's do in this way because I think it's almost 6 o'clock. Okay, we still have 4 more minutes, so I think probably we can add a session now. Then tomorrow let's continue lah. Let's continue with the second ones I'm listed here. I think today basically what we have finished is this part. Okay, I think tomorrow 5 o'clock. Let's continue with the simple extension of this hello world model, so that I will illustrate to you that what are the static dynamic property events, how do we do the randomization, and what is the role of the random seed. And also I think important one thing is I want you to differentiate the difference between the discrete event simulation and the discrete time simulation. So I think maybe tomorrow, like using the extension, maybe I mean consider the questions we are going to discuss. It will take another 1 hour's time. Okay, maybe we do that tomorrow. Ken?
Okay.
Okay.
Okay, so I think, yeah, how do you think about today's session? I mean, personally, I like this kind of the style. I mean, we have this communication, asking and answering question. Yeah.
I think today's session is easy to understand. So
Yeah.
I don't know how about the rest.
Yeah. Any feedback from the rest of you?
Yes, I figured I can catch up.
Okay. I mean, if you still have any question, we still have like 3 more minutes. Feel free to ask.
I don't really understand what's a sandbox. Yeah, the sandbox.
Okay. Sandbox actually is kind of the terminologies used in a lot of like software engineering. Not software engineering, I mean most of the software. It's basically meaning that a safe environment. Sandbox is something like you when you play a toy, like a toy, you actually have this a box. Then inside you have full of sand. Then you can make like a castle. You can make a lot of like different things within this environment. But the thing is, whatever you do is actually within this safe environment. This a box, okay? I mean the box is filled with stands. You can play inside, but whatever you do will not affect the environment outside. Meaning that as long as you don't like dirty put your sands outside, okay, then you are safe inside this environment. Whenever you want to clean everything, you just move this sandbox to the other place. Then you got a clean like a floor, something like this. So in this case, actually, we apply these ideas into the simulation world, meaning that when we want to simulate, we also want to like create this boundary so that everything we do with simulate is within this boundary, within this model. Okay, but when we create a sandbox, we create this environment. When we delete it, okay, it have nothing to do with outside. Okay, so this is why we call this as a sandbox.
Okay.
Okay, maybe you can also like search for official definition of the sandbox. Maybe I can also like search some things on this sandbox.
Thanks.
Huh?
Thanks.
Yeah, it's actually for the testing. Usually it's for the software testing environments. Okay, but basically now it's using this one for simulation. Yeah, because we see that simulation is also an environment we need to protect. We don't want to mix the simulation environments with the outside. And also it's when we have a multiple simulation at the same time. For example, like we have a 2 terminal, okay, design. We have a design 1 and a design 2. So we don't want anything happen in design 1 affect those things in the design 2 because it's actually totally different system we're looking at. Okay, so whatever there's an event happening, we want everything to be controlled in this safe environment. So that's why we use this concept.
Okay.
Yeah.
Thank you.
Okay, no problem.